Now our probability problems will get a little bit more interesting. So let's say I have a bag full of coins. So this is my bag of coins. Maybe it's a bowl of coins. So I have a bunch of coins in there. Right? I didn't need to draw it, but I did anyway. And let's say that I know that 9 of these coins, 9 of them are normal. So what do I mean by normal? It's just, let's say they're quarters and they have a heads and a tails, and that there's a 50% chance of getting a heads or a 50% chance of a tails if you flip any of those coins. And then one of the coins is a two-sided head coin. Two-sided head. So essentially, no matter what you flip it, it's going to be a heads, right? So I have this bag, and what I'm going to do is I'm going to, blindfold myself, stick my hand in the bag, and pick a coin out, and then I'm going to flip that coin. I don't know. I'm going to flip it 5 times. And my question to you is, what is the probability that I get all 5 to be heads? So the probability that I get 5 heads, 5 out of 5 heads. So whenever you see something unfamiliar, it'll always work. It's good to do, maybe we'll do a tree or we'll do a hybrid of a probability tree or something else. But you say, well, at the very beginning of this experiment, something happens. I'm going to pick a coin out of this bag. And so you could say that there's well, how many coins are there? There's 10 coins, and I have an equal probability of picking any one of the coins. Let's say I can't feel whether it's heads or tails. So I'm doing it with gloves on, right? So I can't feel out the two head-sided coins. So you take my word for it. There's an equal probability to take any one of these 10 coins, right? There's 9 normal, 1 weird with 2 heads on it, right? So what's the probability that I get a normal coin? So the probability of a normal. Well, there are 9 normal coins out of the 10 equally likely coins I could get. So the probability of a normal is 9 out of 10. So there's a 9 out of 10 chance that this is a normal coin. Let's just call that normal. And then what's the probability that I get let's call it a 2s, two-sided coin. I'll call it 2s. Well, that's just 1 out of 10. I'm either going to get this or that. I'm not going to take nothing out of the bag, I assume. Okay, so this is a 1/10 chance that I get a 2-sided coin, right? And then whichever coin I get, I'm going to flip it 5 times in a row. And I'm not going to do the tree here because to do a tree, I'd have 32 nodes on each side. But given the normal, what is now the probability of getting 5 in a row? And the way I'm going to write that is the probability of 5 heads, or I could have written 5 out of 5 heads or whatever. And then this upward line, this means given that I have a normal coin. So if I can assume that I had a normal coin, what are the probabilities that my next 5, so I'll say this is 5 out of 5 heads. Well, we figure that out. Each time there's a 1/2 probability, and I'm going to do it 5 in a row. So it's 1/2 to the 5th, which equals 1/32. So the probability that I get 5 out of 5 heads given a normal coin is 1 out of 32. Fair enough. Well, what's the probability of 5 out of 5 heads? 5 out of 5 heads given the 2-sided coin. And this is just random notation. I'm coming up with the 2-sided. But this upward and downwards line, this vertical line, that means given. Well, I'm definitely going to get. I could flip this coin a million times, and all of them are going to be heads. So the probability here is 1 out of 1, right? I'm definitely going to get a heads here. So, what are the probabilities of? So, all I asked initially is what is the probability that I get 5 out of 5 heads? Well, this is going to be equal to, and I will switch colors arbitrarily here just to keep things interesting. This is going to be equal to the probability that you get 5 out of 5 heads given, let's call that a normal coin. Given a normal coin times the probability that you had a normal coin times the probability of, let's say, normal, right? Plus, and I'm running a little bit of space, the probability that you get 5 out of 5 heads given the two-sided coin times the probability that you had the two-sided coin. Hopefully that makes sense, and you can kind of think of it in this way. What is the probability of getting to this outcome? It is the probability that you picked a normal coin, and then, given the normal coin, there's a 1 in 32 chance that you got there. So it'd be 1 out of 32 times the chance you got the normal coin, so 9 out of 10. And what's the probability of getting here? Well, it's the probability that you had to, and in general in a tree, you just have to multiply all of the nodes to get to that point to figure out what's the probability of getting there. And I think if you watch the first few videos, it makes sense why that happens. So what's the probability of this? Well, there's a 1/10 chance that you picked the two-sided coin, and then of course, then you're guaranteed to get all heads. So then this is 1 times 1/10. And all I did here and here is the same thing that I wrote up here. Let me switch colors. So what is this? The probability of 5 out of 5 heads given a normal coin times the probability of a normal coin. Well, that's just this. This is the probability of 5 out of 5 heads given the normal coin times the probability of a normal coin. And this is equal to what? 9 over 320. 9 over 320. And then this, the probability of 5 out of 5 heads given the two-sided coin times the probability of the two-sided coin. Well, this is the probability of 5 out of 5 heads given the two-sided coin. You're guaranteed to get 5 out of 5. And the probability of getting a two-sided coin is 1 out of 10. So 1 out of 10. This is this. So this is equal to 1/10. So my probability of, just putting my hand in the bag, taking out a random coin, and then flipping it 5 times and getting all 5 heads is going to be equal to this plus this. So it's 9 over 320 plus 1 over 10. But let's make that as 300. So it's 320. That's 32 over 320. So 9 plus 32 is 41 over 320. So that's interesting. But now let me ask you even a more interesting question. And this is something that, this is why I think what we've learned so far is useful. Let's say that I do get 5 out of 5 heads. So I know that I got 5 out of 5 heads. So let me clear this up a little bit just because I think it's getting over. So let's say that I do get 5 out of 5 heads. What is the probability that I picked the two-sided coin? So what we're asking is, what is the probability that I picked the two-sided coin given that I got 5 out of 5 heads? And I hope you understand what I mean here. Before we said, like for example, I hope you see the difference between this and what is the probability of getting 5 out of 5 heads, 5 out of 5 heads, given the two-sided coin. Well, this is, if I know I have a two-sided coin, I know that the probability is equal to 1. I know that I'm guaranteed to get 5 heads. But this is a little bit more interesting. If I flip a coin 5 times in a row and I get a bunch of heads, I'll say, well, I either got, maybe really lucky with a normal coin, or I picked the two-sided coin. And I don't know which one happened. So there's a probability I have to and of course, the more times you get a heads, just intuitively, if I got 100 heads in a row, I'll say, well, I probably picked the two-sided coin. Or if I, without actually just looking at the coin, we're assuming that that's not acceptable. And if I got 1,000,000 heads in a row, we'd be really, really sure that we picked the two-sided coin. But we're not completely sure. There's some probability that I picked the fair coin and it just happened to get heads 1,000,000 times in a row. So how do we think about this? Well, I'll do it analytically, and I'll draw it out, and hopefully both of them will make sense to you, and I'll probably have to do it in the next video. I'll see you soon.